Hello everybody and welcome to Norton Live Streams. In case you didn't know, this is a series of live streams we do here at Norton every month, and we'll be continuing with these until the end of the year in December. Before we start, I just want to introduce you to a functionality of the Teams package we're using for these live streams, which is called closed captions. So this is where, if your native language is not English, you can click on the little gear icon in the bottom and select your language, and you'll see subtitles in your language translated from my English. So just to enhance your viewing pleasure, instructions are on your screen as now, or maybe not anymore. Okay, so today's subject is bench and pedestal grinding and how to choose the best wheel for the job you have at hand. Okay, so we've got quite an action-packed 30 minutes for you here, so we better get straight on. So let's have a look at the agenda. Okay, so first of all, we're going to introduce you to the experts we have today. Then we'll have a look at what is a bench grinding wheel, where and how do you use these wheels, what can they do for you. We'll then introduce our Starline range of bench grinding wheels. We'll have a really important section here, which is the do's and don'ts that you should follow for these kind of products. So safety is absolutely paramount with these products. And then we'll have a look at how we dress these wheels and the products we use to dress them. Okay, so those of you who are watching us live this morning, thank you very much for joining. And please, if you have any questions through the stream, pop them in the chat, and then at the end of the stream we'll have a little session which you can stick around for, where we're going to have some live Q&A with the experts we're going to have online today, which we can now introduce to you. Okay, so first of all, it's me. I'm Paul Gray. I live in Cheshire in England. I'm an application engineer for Saint-Gobain for MRO for the whole of Europe. 30 years in manufacturing in total, 18 of which I've spent in a glorious world of abrasives. Now I'd like to introduce to you my esteemed colleague, Mr. Stephen Wood. Steve, would you like to introduce yourself?
Thank you very much, Paul. Okay, so welcome everybody. My name is Stephen Woods. Also live in England like Paul. 19 years in abrasives with Saint-Gobain, and I'm currently part of the European product management team as a product manager for the vitrified tools, including the MRO market.
Very nice to have you with us live as well today. So Steve's made the effort and come and join me for one of our streams today. So thank you very much for that.
Always a pleasure, Paul. Okay,
so we better crack on. Again, action-packed 30 minutes. So we want to set the scene a little bit before we start about the family of grinding wheels we have to show you today. Also about what is a bench grinding wheel and the applications involved in that. A little bit of a PowerPoint. Steve's going to take us through that today.
Sure, mate.
Go for it, Steve.
Okay, thank you, Paul. Okay, so very quickly, very briefly, quick look at the markets. Clearly, it is mostly MRO, maintenance, repair and operation, and some tool shops for sharpening and shaping of tools. A couple of machines are used, bench grinding machines and pedestal grinding machines. The clue is in the name. The bench grinding machine is a smaller machine which is designed for mounting on the bench. The pedestal grinding machine is a slightly larger machine, comes with a pedestal for mounting on the floor for a perfect working height. Okay, look at some of the technical issues of the bench grinding wheels. The recommendation guide is in the Norton catalogue and online.
We'll have a link in the chat.
There'll be a link in the chat.
So please have a look at that if you need to.
Yeah, we're not going to go through all the details yet here because I'm going to show you a bit. But just very briefly on here, you can see there's a range of different grit sizes that are available in your bench grinding wheels. So your coarse grinding wheels are for heavy and medium stock removal. And as you move towards light stock removal and just sharpening or deburring, then obviously move towards your finer grits. And we'll talk about the different types of metals and the abrasive type shortly. Okay, just quickly to introduce the Starline range, because this is our premium Norton Starline range for bench wheels. Comes in the 3 abrasive types we're going to show you in a bit: brown fused alumina, white aluminium oxide and green silicon carbide. Come in a range of grit sizes we've just shown and a range of dimensions to fit most bench and pedestal grinders, including the spindle.
Well, this is an important part, Steve, the safety side of these things, right?
Okay, yeah, we're going to cover a few do's and don'ts. It doesn't cover everything, but we'll start to a few. And these are obviously quite related. So some do's, best handling storage. So the wheels are supplied in cardboard packaging with packing material around it. So please keep the wheel in there while it's not in use and store it safely. When you take the wheel out, do a visual check and a ring test, and we're going to demonstrate this shortly.
That's a really important part, isn't it?
Absolutely, yeah.
The wheel's good to use, right?
Absolutely, yeah. And we'll be showing this after this presentation. And then obviously the don'ts from that is if you do detect that the wheel is damaged or if it fails the ring test, clearly do not use it, okay? Check the machine speed against the speed which is printed on the wheel. Make sure that we are not exceeding the maximum operating speed that is shown on the wheel. Always use the mounting blotters. The mounting blotters are either stuck to the wheel or come loose, so make sure you use them. These are to compensate for any irregularities on the flange so that we don't have any high pressure points which again could damage the wheel.
So the blotter, Steve, just to be clear, is the cardboard ring in the centre of the wheel, right?
Yeah, and we'll show these again shortly after the presentation.
Thank you.
And then one more don't, or a couple more don'ts. Do not force the wheel on the machine. If it doesn't fit smoothly over the spindle, do not force it. It could damage it. And for sure, do not try to adjust the whole of the bench grinding wheel, because again, this could cause cracks or damage to the wheel and could cause an accident. And then these are used for grinding on the periphery of the wheel. You'll see this in a demonstration shortly. It is not designed for grinding on the side of the wheel. Again, you may cause some stress or damage to the wheel, which may cause a breakage.
If you need to grind on the side of the wheel, Steve, there are specific wheels for that, right?
There are specific wheels for that, yeah, but for bench grinding wheels, typically it's a Shape 01 wheel and you grind on the periphery, which is a grinding face, and we'll show this in the demonstration.
Magic.
Okay. We're going to do a demonstration later on dressing, show you how you can affect the performance of the grinding and your workpiece finish.
So what is dressing exactly? Is that actually cleaning the surface of the wheel?
Exactly, yeah. So it's to prepare the wheel so it has a sharp cutting face, and also to remove any loading you may have achieved by grinding on the wheel previously. So we'll have a nice demonstration to show.
Yeah, it's quite an important part of the process, right?
Yeah, yeah. We've got a few tools. We're going to go through the hand dresser and the dressing sticks.
The ring test you were referring to, what can you explain that to us, Steve?
We can, mate. We can do a small demonstration. So first of all, we would do a visual check. So take your wheel, get it in a nice source of light, just check it around, check there's no cracks or defects in the wheel. And this one looks perfectly okay. Next test is the ring test. So just hold the wheel so it's hanging down like this, and then strike the wheel. And what hopefully you get is a nice ring sound.
A nice, like, true harmonic, right?
On the wheel, yeah.
Sure, I can hold that for you.
Thank you, Paul, my faithful assistant.
Pleasure.
Okay, and then what we have here is one we prepared earlier.
Do not use, right?
Do not use is written on the wheel. It's very clear. And I can assure you, when you look around this wheel, you cannot see any cracks or defects in this wheel. Okay, it's a bit dirty, but there is no obvious cracks in this wheel. But this is why it's very important to do the ring test, because when you strike it...
Oh, yeah, very different noise.
Hopefully, what you can hear is a very different noise, and that is telling us there is actually a crack in this wheel. We can't see it, it's not visually there, but there is a crack, a flaw somewhere in this wheel, and obviously if we used it, it could be very dangerous because we could have a breakage.
That could break, as it has a crack inside, that could break in use. So the ring test is absolutely crucial. Before you mount these wheels on your machines, always perform the ring test, which you can do with, we have a special ring tester here, but you can use any little piece of wood. Obviously don't use something hard or metallic to do this with, because you may put a crack into the wheel by doing that. Something soft like this piece of wood is absolutely perfect to do the ring test with, right?
Yeah.
So really important step there, Steve. So thank you for showing us that. Okay, so we're getting to the part where we're actually going to do some grinding now. So before you actually start using these products, it's also good to have all the right PPE equipped, which are actually denoted on our blotters what PPE you should be using. So that's ear defenders, as I've got in here, earplugs, obviously safety glasses, so we don't want any debris getting into our eyes, of course. Gloves, so we want to make sure we're using good gloves that are going to protect us if we ever come anywhere near the wheel, which should never happen. Obviously, a good set of overalls to keep you clean, and safety boots. All right, remember, we're holding components in our hands. If we drop anything, we want to have the right footwear on to protect our feet. Right, so let's have a look at the pedestal machine. So this is the pedestal machine here we're going to be using today. By the way, we also have a bench grinder on here as a backup machine, so if we need to use that, we can do. But this is our pedestal machine we have here. So first of all, before we use this machine, we need to check a few things is okay with it. So first, have a look at the guard. Is the guard in place? You can see here the wheel is guarded within this guard. And this is the main difference. The wheel is almost fully guarded on a pedestal machine. So make sure that's in situ. We have the screen here to protect you from any flying debris on here, so make sure that's in place. One of the most important things about using a machine like this is the platen. Okay, so this is the platen you're going to be using when you're pushing a component into the wheel. What we have to ensure is the gap between the wheel and the platen is as minimal as possible. What we don't want to happen is actually the component we're trying to grind gets in here and gets stuck or jammed between the wheel and this platen, because that could cause us a problem with wheel breakage. So setting that platen in the right place is absolutely crucial for us. Okay, so really important. Wheel mounting is another subject that we'd like to be able to show you today in the live stream, but to be honest with you, it takes quite a while to take these guards off and get the wheel on and put the guards back on. So instead of doing it today on the live stream, because it's so time consuming, we filmed a video already and we're going to put that on our YouTube channel. So if how to mount a bench grinding wheel is something you're interested in, how to do it properly, have a look on our YouTube channel where you can find loads of other videos, but including mounting bench wheels on a pedestal or bench grinding machine. Over to you, Steve.
So Paul's going to do a demonstration very shortly, but just before he does that, what Paul's going to demonstrate is how we choose the right wheel for the job. So we have 3 Starline wheels here. We'll start with the middle one, which is brown fused aluminum, marked A in the specification. We choose this one because it's our most general purpose wheel, works on most steels that you come across. We're going to show you some mild steel grinding today. And also because it's a tough abrasive, has quite a long wheel life, so good value for the money for the customer.
Would you say that's probably the most popular wheel in the market, Steve?
Probably the most popular wheel, yeah, for general purpose.
Because it's quite versatile, right?
Exactly, yeah.
Perfect.
But then some customers may start using some harder metals like tool steel that we have here, very high hardness. And for this type of metal, we recommend going to the white aluminium oxide, marked as 38A in the specification. It's just a purer grain. It's more friable, more free cutting, and will work better for hard materials like tool steel.
But you can grind tool steel on the brown fused alumina, right?
You can grind it, but obviously it will take a longer period of time.
It's going to take slowly. You're going to produce more heat, so it's not going to cut as well. So harder materials, a white AO wheel, right?
Exactly.
Aluminium oxide, I should say.
And then finally on the right we have the green silicon carbide wheel, 39C in the specification. And this we're going to use for non-ferrous materials, and Paul's going to do a nice demonstration there with aluminium.
Okay, right, that leads nicely into demonstration number 1. So as Steve says, we're going to be looking at grinding a soft material like aluminium using these bench wheels. I'm going to use 2 different wheels today. I'm going to use firstly the brown alumina wheel, and then show you what that does to the aluminium when you try and grind this soft material with it. And then we're going to compare and contrast how the green silicon carbide wheel does at the same tasks. So let's get to it. I've got my aluminium bars here, so let's get it on the machine. Okay, so before we start, I'm just going to show you how I'm going to do this. I'm going to put it on the platen here, keep it nice and flat, and just plunge this square bar component into the wheel, and let's see what happens. Right, let's get the machine on and go. Okay. So I think, as you can see, I'll just hold this in the center of the platen here. As you can see, it is removing some material, but very slowly. Okay. And what I can see on the material itself is the material is actually curling round or melting round the end of the bar, causing quite a large burr, which is not ideal. I can also feel the heat inside this material. It's pretty warm. Okay. It's warm to the touch, even through my heat-proof gloves. So it's not really doing a great job at this. Also note the periphery of the wheel. You can see on this wheel there's loads of aluminium now stuck on the surface. Okay, so very quickly this wheel's going to stop cutting, and I'm going to need to dress it and take away that aluminium so I can keep working. So you can clearly see that wheel is not ideal for grinding soft materials such as aluminium. Carbon steel, no problem. Tool steel, yes, a little bit, but materials such as this, you really need to have a look at the silicon carbide wheel, which we will do now. So I've got a new piece of material. We'll do exactly the same again on this side, which is where we've mounted the silicon carbide wheel, and we will repeat, see what we see. Okay, let's go. Okay, so let's have a look at the difference. We can clearly see on this side here was the brown fused alumina. You can see a big burr on there, and the finish is not so good either. It's kind of burning on there too. And on this side, we have the silicon carbide wheel. And there is a small burr, but you can see it's done a much better job. It's not as hot, so it's cooler cutting than the brown fused alumina wheel. So it's done a much overall better job. I could feel the cut speed was a lot better too. Also, have a look at the periphery of the wheel. All right. Yes, of course, it's loaded. It's always going to load. Aluminium is a very sticky material to grind with wheels or belts or whatever. It sticks to abrasives quite easily. But there's a lot less loading on the silicon carbide wheel than there would be than you can see on the brown fused alumina. So you can see a real difference there, guys. You know, again, choosing the right wheel for the material you intend to grind on your bench or pedestal grinder. Steve, anything to add to that?
Nice demo, Paul. Nice demo. It just shows that the green silicon carbide with its sharper, friable grain is just a much more cooler cutting. You don't get this nasty heat generation.
Yeah, you can feel the heat difference in these components still. So yeah. So yeah, the right wheel for the job, as in everything. Yeah. Okay, Steve. Over to you, my friend.
So demo 2. What we're going to do is we're going to look at sort of dressing. So we've got a few sort of dressing tools on here. We'll look at them more closely in a bit, but this is a diamond hand dressing tool on the right, on my right. Then we have a coarse grit black silicon carbide dressing stick, and then a finer grit green silicon carbide stick. So what we're going to do today is we're going to dress the wheel, because Paul has now badly loaded my wheel.
Yeah, I've made a real mess of the surface of these wheels, full of aluminium, so we need to clean these.
We need to clean these.
And that's what we need to be doing with dressing. We're basically, as Steve said earlier in the presentation, we're cleaning the periphery, and we're also getting the grain on the periphery of that wheel ready to do your next grinding. Steve's going to put a dust mask on for this, because it can be quite dusty when you're dressing, and whilst he's doing that, I'm going to get out of the way.
Okay,
over to you, Stephen.
Cheers, buddy. Okay, so hopefully you can still hear me okay with the dust mask on. So this is the first tool. I'll try and show it on here. Okay, so this is the diamond points that you can see clearly in the
so all those black marks are diamonds in there, right, Steve?
Yeah. So it's a very efficient tool and very long wheel life.
Very long tool life. So the diamond dresser lasts a lot longer than a vitrified dressing stick, correct?
Yes, exactly, yeah. Okay. And then what we're going to do for test 1 is we're just going to clean this wheel up, get rid of the loading, and then we're going to just plunge the diamond hand dresser into the wheel to create a very coarse, free cutting surface.
Okay. So you can see Steve there dressing off the aluminium. You see it coming off in quite big lumps, to be honest with you. It is quite tricky to get such a loaded wheel clean again. That's why, again, it's best to choose the right wheel. You see the periphery of the wheel is now clean of aluminium. So this is generally where you wear a lot of the wheel away with dressing, to be honest with you. So again, choosing the right wheel for your job will prolong the wheel life, because less dressing. Okay.
Okay, and then what we're going to do for the grind is we're going to really plunge the workpiece very hard into the grinding wheel. Okay.
So this is a coarse dress, right, Steve?
This is a coarse dress and very high pressure on the grind.
You can almost see the lines on the grinding wheel where Steve has plunged the diamond dressing tool into that. So that's a real quick grind on there, Steve. Yeah,
we're going to show the workpieces at the end of the demonstration.
Okay.
Okay. For the second test, what we're going to use the same sort of dressing stick, the diamond hand dresser. But what we're going to do now is we're going to traverse from left to right to try and create a slightly more smoother surface, not quite so open and aggressive.
You're still using high pressure though, Steve?
Still using high pressure, yeah, but we're going to traverse it across so as it closes the surface a little bit.
Okay. So as you see, Steve, backwards and forward a little bit. So the diamonds are dressing more of the surface and not just in a grooved area like we did on the first grind. Nice and quick to do.
Okay, I'm going to take workpiece 2 and I'm going to plunge it with high pressure as we did with test 1.
Brilliant, thank you, Steve. You see if you can see the pressure Steve's using there. He's pushing in quite an amount, to be honest with you. You can see all the sparks he's producing. All right, on to component number 3. But before you put component 3 on, what you're using now, Steve?
Okay, so for test number 3, we're going to use this green silicon carbide dressing stick. Okay, so maybe not quite the wheel life that you'll get with the diamond hand dresser, but because it's a finer grit, we should be able to generate a smoother surface on the grinding wheel, and that will be reflected on the workpiece.
Is it as quick dressing as the diamond tool?
Probably not. No, not as aggressive as the diamond tool, so not as quick to dress a wheel. But
okay.
when you try to achieve a better surface finish, this is the tool we're going to try today.
Okay. Oh, you can see the surface change there almost instantly. It looks a lot smoother and a lot finer by just applying this silicon carbide stick with less pressure and oscillating back and forth as well, Steve, right?
Yeah, absolutely. And we're going to apply lower pressure on the workpiece as well when we do this final grind to achieve the best surface finish.
Great. Okay, again, you can see the difference in pressure Steve's applying now. There's hardly any sparks this time, so he's really just using the wheels cutting action rather than putting pressure on that component.
Right. So
okay, so you got all three components. Yeah, it's a drastic difference in finish, and that's interesting because that's the same wheel Stephen's used for all three components. And have a look here, the difference in finish.
Okay, so I don't know how clear it is on the camera, but
yeah, we can see it pretty well, Steve.
Good, good, good. This is test one, where we really just plunged the diamond hand dresser into the wheel, generated a very coarse free cutting surface on the bench wheel, and hopefully you can see that's reflected on the workpiece, that you've got some very deep grinding marks and also some burning where we really plunged the workpiece into the wheel. Okay, test number two is where we use the diamond hand dresser again, but this time we traversed it and still plunged the workpiece quite heavy into the bench wheel.
So there's less grooves or marks on
exactly,
item two, right?
Like,
because you've traversed the dresser.
Yeah, so still got quite a lot of burning on there because we're plunging quite hard, generating a lot of heat. But because we've traversed the dresser, we've got a smoother surface on the bench wheel and reduce the grinding marks on the workpiece.
Yeah.
Okay, and then finally, test number three was the fine grit silicon carbide stick. We sort of dressed it down to a nice smooth surface on the bench grinding wheel, and then we applied less pressure onto the workpiece, onto the bench grinding wheel, and just finished the surface. And hopefully what you can see is there's a much better surface finish on the final workpiece.
Yeah, it's really visible, Steve. Yeah. So
excellent.
Again, so to wrap up, guys, you know, it's very important to choose the correct wheel for the job. If you're general purpose carbon steel or mild steel, it's the brown fused alumina is probably the workhorse, I would say, Steve.
I'd say most general purpose wheel, yeah.
Yeah, so you know, no standard kind of materials. Brown fused alumina is the wheel of choice without a doubt. If you're grinding harder materials such as tool steel, then we have a look at the white alumina. The much sharper grain in this,
yeah.
Much more friable, as you said earlier.
So yeah.
It's almost friable means it's almost self-dressing in effect. Is that right? It's just sharp as well.
Yeah, it keeps itself sharp. Yeah,
okay, so it will keep cutting a lot better than the other wheels. And for any other materials, non-ferrous and particularly aluminium, the silicon carbide wheel really does excel in these applications with these kind of materials.
Yeah, so I think that was shown very well in demonstration one, right?
It was a good one, wasn't it, Steve?
And then in demonstration two, we showed, as you saw in the presentation, you can change the wheel if you want. You can use different grit sizes to achieve your best surface finish and achieve higher material removal.
Yeah.
But what you can also do, if you don't want to hold a huge catalogue of these wheels in your workplace and you want to save time by changing the wheel and machine, you can also affect the workpiece surface finish by the way you dress the wheel, as we've shown in the
it's impressive. Even though you're using the same, what is this? What grit size is that?
80 grit.
80 grit. You're using the same grit size, but just that different method of dressing is giving you a completely different surface finish and producing less burn, which is really important on components, right?
No, hopefully it is quite clear from the demonstration you can affect the surface finish of the workpiece.
Very nice to see. Okay, so we've covered a lot in this quick presentation we have here today. We looked at the safety when using these products, which is absolutely paramount, because remember, these are glass bonded wheels, so really important to take notice of the do's and don'ts that Steve went through really about how we put wheels on the machine, how to check the wheel before you do it, the best practice when you're using the product. Also, really importantly, the ring test before you actually mount the wheel, and make sure the wheel is in good condition before you start. It's absolutely paramount of importance when you're using these kind of products.
Yeah.
I think that pretty much wraps it up for today. So those of you who are joining us live, thank you for that. And please stick around because we'll be having our live Q&A session after this. For those who are joining us on YouTube, we'll see you next time on Norton Live. Thanks again, Steve.
Thank you, Paul.
Bye-bye.